Hello, ladies and gentlemen. I hope everyone is doing well today. Today we are taking a look at balancing equations. So we're going to talk about some information on subscripts and coefficients. Hopefully the information on subscripts is a review. Remember, subscripts are a small number that tells us how many atoms are in a compound. So if you had the following compounds, calcium chloride, CaCl2, the little 2 is a subscript, and it tells us that there are 2 chlorine or 2 chloride ions in the formula. So then next, a coefficient tells us how much of that compound we have. So for example, we can look at 3H2O, so 3 waters. The 3 is the coefficient. It tells us that there are 3 waters. So then we know, because water's formula is H2O, if each water contains 2 hydrogens, we can multiply 3 times 2 to figure out the total number of H's, which is 6. We can do the same thing for oxygen. There's 1 oxygen in each 1 water. However, there are 3 waters. So we would do 3 times 1 to give us a total of 3 oxygens. So the next few examples, we need to be able to remove coefficients and parentheses to determine how many of each atom that we have. So the first question, verify that there are 32 oxygen atoms in 4 calcium phosphates. We can use the following. So I highlighted this little 2. I drew an arrow just making sure there's a 2. There's a little glare, so it's tough to see. So remember, that little purple 2 tells us what's inside, tells us how much of what's inside the parentheses. So this tells us we have 2 phosphates. So remember, just like before, we can remove the parentheses by distributing that 2 to each atom. So then what would happen is it would become P2O8, because 1 times 2 gives us 2 phosphoruses, 4 times 2 gives us 8 oxygens, and then the first half is untouched, so we left it 4Ca3. We can then figure out how many oxygens we have, because we need 4 Ca3 P2O8s, and each one of them contains 8 oxygens. So we just need to multiply how many oxygens we have by how many calcium phosphates. So that's why you see me right here do 4 times 8 to get 32 oxygens, and it does verify there are 32 oxygens. So when you're thinking about question 2, you need to tell me how many oxygen atoms are in the following. So remember to use your coefficients when they're given to you. Question 5, or sorry, for 2D. 2D is a little tricky. It's just like the one I showed you. Remember, on this one, just like up here, you're going to have to remove the parentheses first. So distribute that too. So then next we need to think about how to balance equations. So the first one we're going to look at is sodium plus chloride goes to sodium chloride. It is worth mentioning that this is Cl2, not just Cl, because chlorine is diatomic. Whenever it's alone, it's going to bind to itself, makes it more stable. What we need to remember is that our atoms don't disappear. In order for the equation to make sense, we need to balance it so that it follows the law of conservation of mass. Remember, our atoms aren't destroyed, they're rearranged. When we balance our equations, we're going to use coefficients to balance them. Remember, we can't change the subscripts because those come from crisscrossing, so we can't change those, but we can change the coefficients. We can change how many waters we have. We can change how many sodiums we have. So this next example on the next page, I'm going to go through it. Calcium nitrate reacts with sodium chloride to form calcium chloride and sodium nitride. So we're going to begin by balancing one atom at a time. So the steps are over here, 1 through 5. So when I balance equations, what I'm essentially trying to do is I'm trying to make sure that I have the same amount of each atom on the left side of the arrow at the right side. So we do this by going left to right and analyzing each individual atom. So we start with the chlorines. What I like to do is I like to write how many of each I have underneath. It just makes it a little bit more visual, and I can just match the numbers up. So we can start. I have 3 chlorines. Over here, I have 1. Not over here. On the product side, the right side of the arrow, I have 1. So we need to add a coefficient that when we multiply by 1, we get 3. That coefficient ends up being 3 because 3 times 1 equals 3. We next do the same thing for nitrogen. On this side, there's 2 nitrogens on the reactant side. Then we look at the product side for nitrogen. Don't be confused by the page number. I scribbled it out so it's not in our way. On this side, there is 1 nitrogen. we need to add a coefficient to get to 2 nitrogens. So what times 1 equals 2? The answer is 2. So we would do 1 times 2 equals 2. That's how many nitrogens we have now. We do the same thing for sodium. On the reactant side, the left side, there is 1. And then on the product side, there's 2 times 3, which gives us 6. So then we need to add a coefficient to the reactant side. So then when we multiply by 1, it gives us 6. The coefficient we end up adding is 6 because 6 times 1 is 6. And then we do the last thing for chlorine. We double check because we just added the coefficient. So on the reactant side, there are 6 chlorines. And then we double check 3 times 2 on the product side leaves us with 6 chlorines. So that way we know we're done. So remember guys, when we balance equations, we try to make sure that we have the same amount of each atom on both sides of the arrow. When we balance the equations, we never change the subscripts. You only saw me change coefficients. The subscripts come from crisscrossing, so we do not change them. So then next, question 3. So question 3, oops, I left a little bit of information on there. Let me just fix it. Okay. So when we're doing number 3, we need to determine whether or not these are balanced. So I have some numbers written on the top. So we have 2 sodiums, 2 times 1 gives us 2. 2 chlorines, 2 times 1 gives us 2 chlorines. There is 1 copper, there's no subscript or coefficient. On the right side there's 1 copper, 2 chlorines, and 1 sodium. So now we double check, is this balanced? So 2 sodiums and 1 sodium, nope, not balanced. I know the problem didn't ask you to do it, but if we wanted to fix this problem, we would fix it by adding a 2 in the front. Because 1 times 2 would give us 2 sodiums, and now it's balanced. Everything else matches up. There's 2 chlorines, 1 copper, 1 copper, 2 sodiums, 2 sodiums. So that we know we're good. We can do the same thing for B. So we can start with the irons. Fe, there's 1 iron on the left side. We can do the same thing for chlorine. There's 2 chlorines on the left side. We can do the same thing for oxygen, 2 oxygens. Now we move to the right side. We do the irons. 2 times 1 gives us 2 irons. 2 times 1 gives us 2 oxygens. And then there's already 2 chlorines. So now we can double check this and make sure that it's balanced. So we look, 1 iron, 2 irons, so we know that it's not balanced. How I know the problem didn't ask for it, but we can fix it again. We can fix it because we know that we need to have 2 irons on both sides. So we can add a coefficient of 2 to the reactant side, because 2 times 1 would give us now 2 irons, not 1. We need to double check and see how it affects the chlorines, because remember chlorine is also in this problem. So look, we see 2 times 2, so now we have 4 chlorines. Do the chlorines on the product side match up? No, we have 2. So again, we would just add a coefficient. We can add a coefficient of 2 because 2 times 2 equals 4. Now every coefficient is balanced, or every atom has the same amount of each side on the left side and the right side. So guys, now I'd like you to try to do 4 similarly to how I did the problem in the notes and how I solved 3. Double check and make sure is there the same amount of each atom on both sides of the arrow. So next we're going to move into some information on polyatomic ions. So when we balance polyatomic ions, just like when we name, the rules are exactly the same. We're just going to maybe pull some ions from that polyatomic ion list. One thing worth remembering about polyatomic ions is we never break them up. So in these problems, when you're thinking about SO4 and PO4, don't think about SO4 as sulfur and oxygen. Think about it as sulfate and balance the sulfates. Same thing with phosphate. Don't think about phosphate as PO4. Think about it as phosphorus and oxygen. Think about it as phosphate and balance phosphate. Don't think about it as phosphorus and oxygen. So we start these the same way. We start with sodium on the left side. On the left side, there's 2 sodiums, and on the right side, there are 3. So we need to figure out a common multiple. The common multiple between 2 and 3 is 6. So we would add a 3 to the coefficient to the left side, because 3 times 2 equals 6. We had a coefficient of 2 to the right side, because 2 times 3 equals 6. We next move to the sulfates. So we look at the sulfates on the reactant side. We just added the coefficient of 3, so now there's 3 times 1. Remember, sulfate is SO4. If we were to add parentheses, it would look like that. So the 1 would be on the outside telling us 1 sulfate. So now we would see 3 times 1, which means we have 3 sulfates. So then we need to look at the other side, make sure there's 3 sulfates on the product side. There's only 1, so we need to add a coefficient. 3 times 1 equals 3. So the coefficient we add is a 3. We next move on to calcium. So we notice that there's 3 calciums on the reactant side, so we write 3. Now we look at the product side. Again, we need to distribute the coefficient of a 3. 3 times 1 is 3, so then we know there's 3 calciums. We now check out the phosphates. On the reactant side, there's a 2, so we have 2 phosphates. Don't forget, guys, you added a coefficient to the product side, so now we would do 2 times 1 phosphate, which gives us 2. Remember, this is 1 phosphate because phosphate is PO4. You need to have 4 oxygens for every 1 phosphorus to make phosphate. Just like water is H2O. You need 2 hydrogens and 1 oxygen. So that's how we balance our reactions with polyatomic ions. We don't break up the polyatomic ions, and we think about them as sulfate, phosphate, cyanide, whichever polyatomic ion you have. So then next, question 5. Question 5, we can do the same thing we did before. We can double check the balancing. So we can start with A. So we have 1 barium on the reactant side, 2 nitrates on the reactant side. We do the same thing for the next one. There's 2 irons, 2 Fe's. There's 1 sulfate, SO4. Now we move to the product side. Don't forget to distribute when there's a coefficient. So right now there's 2 irons. Then we also see there's 2 nitrates. Now we do the same thing for barium and sulfate. There's 1 barium and 1 sulfate. So let's go through barium and barium matches, nitrate and nitrate matches, 2 irons, 2 iron matches, 1 sulfate, 1 sulfate. So those ones are balanced. There's nothing to change. And then lastly, 5B. So we do the same thing. There are 3 strontiums, 3 SRs. 3 times 2 gives us 6 chlorines. We look at the subscript because there's no coefficient, so there's 1 aluminum. And we see right there that there would be 3 nitrates. Now we do the same thing on the product side. Distribute, so there's 3 strontiums. 3 times 2 would give us 6 nitrates. And then we already see 1 aluminum and 3 chlorines. So, we can double check this and make sure that's balanced. 3 SRs, 3 SRs. 6 chlorines, 3 chlorines. Oh, it's not balanced. So how can we fix this? We can add a 2 in front. Because 2 times 3 gives us 6. So now our chlorine's balanced. So now we can check the aluminums. Oh, don't forget 1 times 2 now changed how many aluminums we have. There are 2 aluminums. So now we need to add a coefficient to the reactant side. So there's 2 aluminums on the right, 1 on the left. So that means we would add a 2 because 2 times 1 gives us 2. Now we can double check the nitrates. 2 times 3 gives us 6. And there are 6 nitrates on the other side. So we know that that reaction is balanced. So guys, now what I'd like you to do is to finish up this chemquest. So balance the reactions in question 6. Remember, don't break up your polyatomic ions. Question 7. Question 7, I want you to complete the reaction based on what type it is, whether it's single replacement, double replacement, combustion, synthesis, or decomposition, and then balance it when you're done. Like always, if you have any questions, please bring them to class. I hope everyone has a good day. Bye.